Part 2 of day 20, we're going to summarize the product of binomial conjugates. Again, we talked about in the last video, when two binomials multiply together, we use the FOIL process. And when those binomials are conjugates of one another, we're starting to see a pattern form in their end result. So in general, we'll use A and B here to represent our two binomials and a conjugate pair of binomials. We recognize that the first product is going to be an a squared. The outside product is a negative ab in this case. The inside product is a positive ab, and the last product is a negative b squared, or minus b squared. Every time that we produce a product of binomial conjugates, these center two terms will cancel. They will always disappear if we multiplied by binomials that were conjugates of one another. And so what that leaves us with is an a squared minus b squared as our final form. This has a special name to it, this binomial here. Again, it's a binomial. It has two terms, and every single time that we complete this multiplication, the terms will be subtracted from one another. And so another name for subtraction is difference, and since each term is a square number, we call this a difference of squares. Now, if I present to you a difference of two squares, or a difference of squares binomial, then sometimes I may ask you to undo this result. And if we undo a polynomial like this and return it back to its binomial factors, that's called factoring. So in this next section of the video, we're going to complete some examples of factoring. More specifically, factoring difference of two squares. Let's try this first one here in this group. Suppose I give you y squared minus 64. First, we should double check, do we have two square numbers? And the answer is yes, because y squared is a square number and 64 is a square number. Each of those have a square root. What you should immediately recognize then is that a difference of two squares will always factor into binomial conjugates. So the elements of the binomial conjugates are the square root of both the first term and the second term. So in this case, I'm working with a y as the square root of y squared and an 8 as the square root of 64. Since the result is a binomial conjugate, we need to remember that one of these signs is positive, one of these signs is negative. So the result, the factored result of our difference of two squares is y plus 8, y minus 8. Here's another example. Let's start with 25a squared minus 81. First things first, we have to investigate this. It looks like a difference of two squares. We should verify that each has a square root. This one's easy to see. The square root of 81 is 9. This first piece might not be as obvious to you, but you should be able to quickly determine that this is a square number. Since it's a product of two pieces, both a number and a variable, each piece has to have a square root. So since 25 has a square root being 5, and a squared has a square root being a, then we know that both the first term and the second term of our binomial up here, both are squares, and they're being subtracted with one another. So this is what we call a difference of two squares. Difference of two squares always factors into two binomial conjugates. The first entry of each binomial is a square root of my first term here. And the second entry of each binomial is the square root of the second term. So we have 9 and 9. One sign will be positive, one sign will be negative, and now we have a factored result for a difference of two squares. Here's another one. X to the 6th power minus y to the 8th power. Well, we have two terms that are being subtracted, so we know we have a difference problem. We need to verify whether or not x to the 6th power and x to the 8th power are both square numbers. because if they're not square numbers, then we may not use the shortcut that we're discussing here in this video. But if we think carefully, you should recognize that both x to the 6th power and y to the 8th power do have square roots. Remember, a square root means that we must find something that multiplies together twice, multiplies by itself 2 times to equal x to the 6th power. In this case, that would be x cubed, because x cubed times x cubed would equal x to the 6th. Same thing with y to the 8th. The square root of y to the 8th would be y to the 4th power. So knowing that the first and the second term both have square roots, and they're being subtracted from one another in this setup, we have a difference of 2 squares. The end result would look something like this: x cubed in the first position of each binomial, y to the 4th in the second position of each binomial. One binomial receives a positive sign, the other one receives a negative sign, and we're left with x cubed plus y to the 4th and x cubed minus y to the 4th. That's our factored example of this difference of 2 squares. I spoke awfully quickly in these 2 videos, with the intention of creating several examples for you to look at. If you find that I went too fast for you to follow, please go back and rewatch the videos and make sure that you understand the process here. We will have time to practice tomorrow in class, and we're going to work through these example problems from the packet.